2 hours can you service graduate?
Here is the second part of the homework for tonight. Okay, what you're going to do is you are going to graph y equals -3, instead of cosecant, what's the reciprocal?
Sine.
So what does this look like? We did these last week. Where's your new asymptote?
4.
At 1. So you're going to draw a new asymptote here. Now, the sine curve normally starts on and it goes up. The amplitude is 3. But because it's a negative,
Down.
what are you going to do? Instead of going up 3, you're going to go.
Down 3.
So it starts on and you're going to go down 3. 1, 2, 3. Put a dot. Back on, above, and on. So we're going to graph 2 full periods. So if you want to real lightly graph, this is the sine curve, -3. This is real light. Now at your zeros, you're going to have asymptotes. So right here, you're going to draw vertical asymptotes, because if you were to flip these points, it would be undefined. Does that make sense?
All the ones that are on, right?
All the ones that are on are going to be asymptotes. So now what you have here, all of these highs and lows are going to be little parabolas. These are actually the graph. You want to stay within those asymptotes. Okay? So first start off by graphing the reciprocal function, -3 sine t or x plus 1. So it's shifted 1 unit up and it's going backwards. And then the zeros are going to be your asymptotes, and the stuff in between are going to be your little parabolas. Okay? Okay, the next one, number 11. Where are you going to, are you good?
No.
No? Okay, I'll wait.
I can read this as well.
Yeah, me too.
These 18 are homework. You ready for the next one? Okay, number 11. What are you really graphing?
Cos -2 cos.
Mm-hmm.
Plus 2.
Start where?
Plus this is 2.
2. Make a broken. This is your new x-axis. Okay, the cosine curve upside down is where, instead of starting high, you're going to start down here at -2, well, 2 down from the x-axis, and then you're going to go up, or on, I should say. So it's below, on, above, on, and below. So what you have here is this, looks like a bell. Is that your answer?
No.
No, that's not your answer. What's your answer? Some people like to do different colors,
That's pretty.
make it fancy. You want to contrast your answer. So this, this. Now, they're asking you to graph from -2 pi to 2 pi. So you want that piece and that piece. Number 12.
1/2 sine.
Okay, what would you do? I'm gonna change my scale. I'm gonna make these each go by halves. So in other words, this is 1, and this is -1 right here. Does that make sense? Because to do a half, it's too squishy. So what am I graphing? I'm actually graphing 1/2 sine x minus 1. So minus 1, which is this line right here, is your new x-axis. What's my amplitude? A half. So it's gonna start here, it's gonna go, these are a halves now. Up, down, like that. Does that make sense? Just so it's not so squished in there. And that's okay, as long as you label what everything is. So you have your new x-axis. And I went from negative 2 pi to 2 pi. That's it. Number 13. Where do I start?
2 equal 3 sine x plus 2.
Mm-hmm. So tell me what to do. I want a good graph.
Start at 2.
Mm-hmm. Start at 2.
And you go start from the middle.
You're gonna start here, you gotta know what the sine curve looks like. What does the sine curve look like with a 3?
Up 3.
You're gonna go up 3,
Back on.
on. So it looks like this. Okay, so now what? Where are your asymptotes?
On the line.
At negative 2 pi, negative pi, 0, every pi. And now what does your graph look like? That. That's it. You should have arrows at the end. Two up. And it's the sine curve. Thumbs up. Courtney, you good? Yep. John?
Yep.
Lily? Next. Nick?
Hmm.
Are you good?
Moments.
Almost?
Yeah.
Matt?
Yeah.
Trevor?
Yeah.
Troy?
Mm-hmm.
Samantha?
Yep.
You get it?
You get that? Okay.
Okay, so tell me what to do on this next one.
Negative 2 sine of x minus 1.
So you're not graphing the cosecant, you're gonna do the sine. Where's your new x-axis? Right here, negative 1. So instead of on above, you're gonna go on, where? I'm doing the sine curve. So it's below, because it's a negative 2, so it's backwards. So you go down 2, your amplitude is 2, down 2, back on, up 2, so it's backwards. Now where are your asymptotes? At negative 2 pi, at negative pi, at 0, at pi, and at 2 pi. So what does your graph look like? Just like that. Yes or no? Good? Anyone not? For this one, I would change my scale. I'd make these each half. I'd make that one and this -1. So where are you gonna start at? That would be -1/2. And I'm gonna graph the cosine curve. What does the cosine curve look like? It normally starts high, but this one's gonna start low, because it's negative. And it's gonna go, these are really a half, but it's upside down. Looks like a bell. Now, as long as you rename your axes, so these are halves, you'll be okay. Whoops. Whoops, whoops, whoops. Fix this. Your asymptote should be at 3π/2. Starting to get dizzy doing these. Okay, so your graph should look like this. Here, 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 and then these should be half ones. Questions on that one? So understanding that each of these dots is a half. So you started at -1/2 and you went down 1/2. These are all halves. Questions? Anyone? Can I move on to the next one?
You deserve round.
Okay, what do I do on this one? -2 what?
Cosine. T -1.
So where do I begin?
-9.
At -1,
You go down T.
and I'm gonna, instead of starting too high, I'm gonna start too
Low.
low. Too low. Too low. Your asymptotes are at the π/2s. 3π/2, 2π/2. Okay, number 17. Oh dear, we have to fix this one. So, let me talk about real quick. What's the difference between this one? See if you remember from last week,
No.
the absolute value. You remember?
It's all
Do
positive.
absolute values.
This one looked like this. So what do you think? What do you think? How would you describe the difference?
3 to 4.
All positive.
Huh?
3, 4.
No, okay.
Like, okay, one like
So
One's
goes,
got 2.
yeah, one is
two
split
sets.
between it and one is like divided.
One's got, yeah.
Yeah,
Okay, so we're gonna call this valley in this splitting the mountain.
Oh,
Okay?
that's the difference.
So, how would you, first of all, we have to fix this
It's
one.
just 2 plus.
So this is gonna be up 2. right, up 2.
And then 2.
And the amplitude is 2. Is it the one is it a valley or is it gonna split it in the middle?
Yeah.
It's a valley, so we're gonna go like this. Like that. You guys with me? So if you were asked to graph 2, now if it were a -2, these would be upside down, they'd look like waves. So now, is this the answer? No. You've got, at your zeros, you're gonna have, now you're doing the cosecant graph. So you're gonna have this. And so your actual answers are,
For you.
in pink. And the last one. Tell me what to do. Begin at where? Mhm. Start at -2. Where do I go from here? Where do I go? Tell me. Do I start
Down
high? Do I start low? Do I start where?
Low.
Low?
Yeah. Negative.
Right.
Oh, high. Duh.
High?
High.
No.
Down.
On it, on
On.
Trick. That was a trick
I
question.
tricked you guys. On.
Bazinga.
Now am I gonna go high,
Low.
low, 3
On.
down?
High. On.
So it's, for this one, it's the sine curve.
I need that. No.
Okay, next, what do you do?
Draw the
Where are your
asymptotes
asymptotes?
at the zeros.
At the zeros. But they're every pi, right? Right,
Indeed.
Troy?
Indeed.
Okay, so what is your graph gonna look like?
Zoop. Yeah.
Doo doo doo. I got Harlem
Can I press the
Shake
button
stuff in
now?
my head. That's okay. Good job, team.
Hold on. Now, you have to do 1 through 9, so that's the second half of the homework. You can do that off.
Ready?